in a finite geometric sequence, we've got term 1, so here's term 1 is 7. And then we don't know term 2, term 3, term 4, but we know that term 5 is 567. Sometimes I like to draw this out just sort of to visualize this. And I need to find term 2, term 2, and I need to find term 6. So it would be really helpful if I knew what I was multiplying by. Now if we go to our formula sheet, we have the following formula for geometric sequences, that any term is the first one, and then times by r, n minus 1 times. I don't know r. So the question is, if you don't know something, and you look at your formula, you ask yourself, do I have enough information to put everything else in? Obviously, term 1 is only one thing. Do I know term 1? Yes, it's 7. Term n can be any one, and general term, it can be any one I want. So do I know any other terms? I know term 5. So if I plug in 567 for term 5, that also means I have to plug in a 5 for the n, and term 1 is 7. So this would be a calculator question. If you divide 567 by 7, you would get 81. Okay, so maybe you don't need a calculator for that, but you could plug 5 minus 1 into your calculator and you get 4. And then how do we solve for r? What's the opposite of doing a power of 4? Close to square root has a close. One more number?
Quadruple root.
Fourth root.
Whatever.
Yeah. We do the fourth root. And just like square rooting both sides, when you do a fourth root, any even root, you need to add a plus or minus. So our r value here, and again, you could go to your calculator to do the fourth root. You might want to see if you know how to do that on your calculator. Yes.
What does the plus or minus mean?
The plus or minus is it's either positive or negative. Like for example, with squared, if x squared is 9, 3 times 3 is 9, but minus 3 and minus 3 is also 9. So we need to show that we recognize that there's more than just the plus answer. So a typical mistake would be just okay. So now that I know it's plus or minus 3, that means that term 2 is either 21 or negative 21. And if I take 567 and multiply that by 3, this could be 1701 or negative 1701. Then part B, then for part B, I'll just do it right here, right beside. It says the last term is 45,927. How many terms are there in a sequence? So when they tell you a last term but don't say how many there are, you don't know n, but you know that there is a Tn that's equal to that. So again, in our general formula, right, this Tn, this is a general term. It can find any term you want, and a lot of times, the term that you want to find is the last term. And that's what's happening in part B. So I know the last term, even though I don't know n, I can plug in 45,927. I know my first term is 7. I know now that my r is either plus 3 or minus 3. So we can solve it for either one. I'm going to use plus 3. You could also try it with minus 3. It's going to be one or the other. And I don't know n minus 1. So again, if I divide both sides of this by 45,927 divided by 7. And now you need to solve for n in an exponent, which is something mathematically, up till now in grade 11, you have not done formally. In fact, we will not do it formally until next year. It requires something called logarithms. But with that, you will still be able to figure this out. Why can you still figure this out? Does it make sense that n is not going to be a decimal?
Yeah.
So as far as guessing and checking goes, it's not going to be that hard to find. And what I would do is I would take out my calculator, which I'll do right now. And this 6,561 must be 3 to the something. So I'm going to take out my calculator, and I'm going to try 3 to the, give me a number. Hopefully you get it wrong. 7. Too small. So now if it's too small, and you do the next guess, I'm hoping your next guess is not 3 squared. That would be a really bad next guess. For one, I hope you know what 3 squared is in your head. That is 9, right? And the fact that you got it too small. What do you want to try next? 8, okay? And I also hope that your next guess wouldn't have been like, oh, 7 was too small, I'm going to try 36. Oh, that's way too big. So, does it make sense that you have a little bit of, you're guessing, but you're not just randomly guessing here. We are using some sort of logic. And we figured it out that 3 to the 8 was 6,561. So now I can replace the 6,561 with 3 to the 8. And if 3 to the 8 happens to equal 3 to the n minus 1. What could n possibly be? N has to be 9. So there would be 9 terms in this sequence. Yes.
I still don't really understand why we're doing the plus or negative on the
So mathematically, whenever you're solving a power equation that has an even exponent,
yeah.
like x squared is 16, you would have to square root both sides. But if I just write this, and I go to my calculator, technically, the square root of 16 only has one answer. Here it is. Square root of 16 only has one answer, which is 4. But if I go back to my question, there's more than one thing that you can square to get 16. You can square 4 and you can square negative 4. So when we take the square root of both sides, mathematically we have to show that we know that by adding the plus or minus, because the square root of 16 is only positive 4. By adding that plus or minus, we say that the answers are 4 over negative 4.
So it's only even exponents?
Only even exponents.
Okay.
Because with odd exponents,
It's either one or the other.
right, the only way to get 8 is 2 times 2 times 2. If I do negative 2 times negative 2 times negative 2, I get negative. So it's only with even exponents, so you'd have to do it with a 4. If it was a 6, you would have to do it. If it was an 8, you'd have to add the plus or minus. But it's only with those even ones. Okay, so circle questions 8, 9, and 11. And we're going to do example 4 together.